Welcome to 2019 question. It's question A-1. So the image shows a multi-story building in Chicago. The front of the structure is comprised of a series of glass panels. The drawing shows projections of three similar glass panels, ABC, BCD and CDP. Determine the dihedral angle between the surfaces ABC and BCD. So what we're looking at here is an intersecting planes question. Okay, so we're dealing with this plane here, purple plane, which is CBD. Okay, and we're also dealing with ABC. So we want to find the dihedral angle between those two planes. So essentially what we want to do is we want to find the true length of the line BC. And if we find the true length of the line BC, we can look along that point. So we want to look perpendicular to line BC, see the true length first of all. So sliding set squares. Set up our XY line out here. So that's our X1, Y1, and we're going to project out everything perpendicular to that. So we're creating an auxiliary elevation. Right, the reason we know it's an auxiliary elevation is we're projecting from plan to an elevation. Same way we project from plan to an elevation here. Okay, because it's an auxiliary elevation, we take our heights from our elevation. So height of A, step it off here, height of C, that off, B, and D. Okay, so join those up, we got C, A, B, and D. So AB is the key line that we're looking for. I'll draw in the rest of these planes as well. Okay, so like I said, CB, that is a true length line. If we shade in these planes, okay, but this is our true length line. Okay, we now want to look out along that true length, see it as a point view. If I see that intersecting line as a point view, that means I will see the planes as edge views. So my X2, Y2 line project on the points out. Okay, so we've projected from a plan to an auxiliary elevation and then onto an auxiliary plan. So the heights, I have to come back two views to a plan to get them. So distance from A to X1, Y1. Let's step off here for A. Distance for B, which is the same as the distance for C, a step off here and get a point view of those, and then my distance for D from my x1, y1, step that off here also. So we've got A, we've got B, C, and we've got D. So it's almost a straight angle. Okay, so that's my point view of BC. Here's my plane ABC and my plane BCD. Okay, so that is the angle, the dihedral angle between those dihedral. Okay, so that's part A completed. Part B then, draw the elevation and plan of a horizontal line on the surface CDP, so it's CDP. We want to draw a horizontal line which will pass through point P. Okay, so we're going to draw a horizontal line there. Determine and indicate the degrees. Determine and indicate in degrees the inclination of this line to the vertical plane. Alright, so we want to draw a line through P, as they're asking us, that is horizontal. Okay, so we've got a horizontal line now passing through P. They want us then to determine the inclination of this line to the vertical plane. So as we're looking at this elevation, okay, the vertical plane, okay, is there behind it. So it's hard, it's impossible in the elevation to determine that. But in plan view, if I can find this line in plan, that will appear the true length line. Okay, so imagine it somewhere there. Okay, true length line. And my vertical plane will be here, so I'll be able to determine the angle between both of those. So we'll call this P. So point 1, let's find point 1, which is on CD. So there's point 1. So here is the true length of that line. And we said, if I imagine my vertical plane is running here in plan, I can extend that line on, and that will determine the angle of inclination of that line. So here, this angle, okay, is the angle of that. And sorry, they're asking us to indicate it in degrees, so I'm actually going to need to have to extend this out just for my particular protractor. So that is at 26 degrees. So 26 degrees. Okay, so that is question A1, nice intersecting planes question in 2019.